All right, so let's get started with complex numbers. And in this video, we talk about, again, a revision of what um, the polar form of a complex number polar form of a complex number is. And we also talk about, and this is also called the modulus argument form of a complex number. And we also talk about locus involving complex numbers. So very quickly, we'll go over the polar form of a complex number. Now we already know that the Cartesian form of a complex number looks like this: x plus yi, where x being the real part of the complex number and y being the imaginary part of the complex number. However, we can express this in another form involving something called a modulus r of the complex number, as well as theta, which is the argument, or also called the principal argument of a complex number. Now, if we were to represent this in a diagram called the Argand diagram, this being the imaginary axis and this being the real axis, x plus yi would look something like this. So the number x plus yi would look something like this. And if we were to connect a line to the number from the origin, this is what it would look like. However, this form involves x and y, the Cartesian form. But the other form that we'll be talking about, which involves the modulus and argument, do not quite involve these guys, but involve what we call the modulus, which is the length of this line, and the argument, theta, which is this angle. Now the question is, how do we go from this particular form to the polar form of the modulus argument form, meaning how do we introduce the values of r and theta? Well, if you use trigonometry, sine, cos, tan, basically, and in this case, sine and cos, you'll figure that the x value is essentially the length of the line r times cos theta, theta being this angle, of course, in radian mode, and the y value is essentially r into sine theta, which, when you plug in here, gives you the complex number being r cos theta plus r sine theta I. R, when taken common, gives you the whole thing gives you r times cos theta plus sine theta I. Now, this right here is what we call the polar form, or the complex argument, modulus and argument form of the complex number. Now, if we said this was z, this particular number was z, we would also say this particular number is z as well. Now, an example would be, and in case you do not remember what the modulus actually is, again, modulus r of a complex number, if your complex number is z, uh, will also be given by this, can also be given by this symbol, is equals to root over of the real part square plus the imaginary part square. Now, this is something you might have to remember as well. And the argument is essentially this angle. And we talked a bit about argument before, where we said argument is always between minus 180 degree and 180 degree, or minus pi to pi, and that it is always measured from the positive x-axis. And in case the angle is below the positive x-axis, we use negative angles. For example, if our number w looks something like this, we would be giving this angle, which is, let's say, negative 120 degree, but mostly given in radian mode. So we did talk about argument. So that is our principal argument in radians between pi and minus pi and pi. So that is essentially what the polar form or the principal argument form of the complex number is. Now, hopefully, that does explain the concept to you. Now, if you do want an example, though, well, mostly what you do need to know is how do you convert between the two forms. Now, if I give you, for example, example w is equals to 3 plus 5i, and I ask you to convert this Cartesian form into the polar form, you need two pieces of information, one being the modulus, which is essentially root over of 3 square plus 5 square, which is 9 plus 25, which is root 34, and also the argument. Now, in order to calculate the argument properly, you might want to do a quick sketch of the number so that you know in which quadrant it is. So this one is very simple, 3 comma 5. This is on the first quadrant. So the argument is this angle and no other angle. Now, considering 90 degrees, you should realize that you can use something called the tan function. So in this case, the tan function would be opposite by adjacent. So in this case, the angle is going to be tan inverse opposite by adjacent. Now calculate this in radian mode and put this and the value right in here. R এর জায়গায় তুমি √34 বসায় দাও, সাবস্টিটিউট করো, cos theta plus sin theta I theta এর জায়গায় হচ্ছে এই ভ্যালুটা বসায় দিলেই হবে। So hopefully that explains the concept of um, hopefully that explains the concept of the the Cartesian form and the polar form, or the what we call the modulus and argument form of the complex number. In the next video, we talk about this new concept of locus involving complex numbers.